Good morning, guys. Today we're still not going to finish the entire 6.3. Today we're only going to look at examples 4 and 5. Tomorrow we're going to just see the rest because I don't want you guys to get confused. It's going to start getting a little tricky, especially tomorrow. So for example 4, before I begin the class, I want to say that, students are asking really good questions, so congratulations. Most of you are turning in the homework. Good job. Remember the exam we're going to have next week. I'm going to let you know on Monday or Tuesday what we have to start studying. First of all, the student said yesterday, Profe, pero I'm hitting log, 4 in my calculator and I'm getting a very weird decimal. I don't understand what's happening. The problem is that you're actually not plugging in the correct numbers, and let's see why. If I look at this x, what is the degree of that x? Well, it's a first degree. Pero, profe, there's not a 1 there because by default, when you don't see anything there, that means it's a power of 1. Likewise, what is my denominator here? It's a 1. Profe, but I don't see it. Well, because by default, when you don't see a denominator, that means it's always 1 because 4 divided by 1 is 1. Profe, what's my leading term there? Is it a 0? No, it's a 1. Whenever you don't see it, it's because it's a 1 there. Just people don't put it. Now, with logs, it's similar but with a slight difference. Whenever you see a log without a base, whenever you see a log with no base, I have no base there, that means it's actually a 10, not a 1. It's a 10. Log 10 of 100. So what number do you raise 10 by to end up with 100? 2, because 10 squared is 100. So again, in your calculator, if you hit log 100, you should get an answer of 2. Because whenever we don't put an actual base and you just hit log, the calculator is understanding that you're dealing with a common log, and all common logs have a base 10. I repeat, common logs are logs of base 10, and you write them in this fashion. If I tell you what is the base here, it's 10. Plug that into your calculator, you'll get a crazy variable, crazy decimal. That's pretty much it for common logs. The other part is natural logs. You'll see that your calculator also has an LN button. That means natural log. A natural log is a log with the base E, the natural base, which we saw earlier with exponential growth and exponential decay. You'll see how that plays in a little bit later. So every time you use this button in your calculator, you know the calculator is reading log with base E. And also, when you're going to write an answer, please never write this and don't ever write this. If you're going to have a base 10, you just write log, because I know it's a base 10. If you're going to have a base E, do not write log base E. You just write ln, natural log. Now, your calculator has an easily accessible log button for common logs and also has an easily accessible ln button for natural logs. Now, whenever you want to find a different log, like for example this, what you do is you go to, in your calculator, I don't have a graphing calculator right now, but one of the options, I think you go to math. You hit options or math, the math button. It's going to give you a list. It's going to give you a list of options. I think you always go down to actually the last one. It's going to give you one that looks like log base, something like this. When you select that option, you're going to end up with something that looks like this. It's going to allow you to put this number here, 3, and it's also going to allow you to put this number here, 9. When you hit enter, you're going to get the actual answer. So if you use this, know that the calculator is going to calculate log base 10 If you use this, know that the calculator is going to automatically use log base e. If you want a different log base that isn't 10 or e, like this case, you have to go to the math option log base and find this expression. Remember, you gotta find log base. You hit enter, the calculator is gonna give you these like little blocks that you need to fill in, or sometimes parentheses, depending on the calculator. You plug in the values that you want, boom, problem solved. So that gets rid of so now that takes care of example 4, common and natural logs. Now, we're gonna go over example 5. Today's a pretty short class, so just again, make sure you review, you practice, you understand perfectly. If you're not understanding, I repeat, let me know, we'll set up a video call. Now, in order to use the inverse properties, let's see. Remember, I mentioned earlier that when addition and subtraction are inverse, multiplication and division are inverse, and exponentiation or exponents and logs are also inverse. So let's see. Let's say you have a particular value, and then I add something, and I also do the inverse. Nothing changes. So these two cancel out. If you have a value and you multiply by 2 and then also apply its inverse, the multiplication and the inverse cancel out. So whenever you do an inverse, whenever you apply an inverse operation, you're canceling out its opposite. So let's see how that works with logarithms and exponents. Let's look at example 5. Let's say I have this expression. Right now, this is a power, and this is a log. And powers and logs are opposite. They cancel out. Now, what number is this? 10. In order for this to cancel out, the number has to be identical to the base. And since they tell me log, you know that's a common log, and that's the base. So these two would actually cancel out, and that would be the exact same thing as 4. If you plug this expression into your calculator and hit enter, boom, you would get 4 back because these cancel out. Remember, these numbers have to be identical. So again, if I give you 7 and then log 7, 17, these cancel out. The answer is 17. If I have 1/2, log 0.5, 17, 1/2 and 0.5 are the exact same thing. They cancel out. The answer is 17. Note, and it's very important, 17 log 17 of 3 and 17 log 17 of 3 are not the same expressions. Here, this is a multiplication. Multiplication and logarithms are not inverse. Here, it's an exponent, so you have to be very careful. Here, it would not cancel out. Here, since it's a power and a log, which is the inverse, it would cancel out, and this answer would be 3. Now, let's see another case. Let's see in example 5, let's look at B. So I'm told log 5 25x. Oh, also another thing, and this is important. Another thing. If I have, for example, log 9, 3, here it would also cancel out. It would just cancel out, and you end up with a 3. This would not be the same as this, log 9, 3. This is a multiplication, but this is fine. This base is identical to this log, so it would cancel out. And this is going to help you with this example. Now, right now, these two numbers are not identical, so I can't cancel it out per se. However, you have to try to make these two numbers identical. That's always how these problems are going to work. Either they're going to give you a number, for example, identical to a base, and all you got to do is cancel them out, and that's your answer. Or they're going to give you numbers like this, which aren't identical, but they are related. Is 25 not the exact same thing as 5 squared? Is it not the exact same thing? Yes, but I still can't cancel out. Why? I have to get rid of the 2 that's inside the parentheses. Now, if you remember the rules of the powers and exponents, which you should know, or you're going to start having a lot of trouble from now on, power of a power, you just multiply. So this expression is identical to this expression. I multiplied the 2 and the x. Now, are these two numbers not the same? Yes. Cancel out. What am I left with? 2x. That's the answer. So again, the whole point is to try to end up with either the base and this number identical so we can cancel them out, or the number and the base of the exponent up here, they have to be identical. Está bien? You'll see how it's going to get a little bit complicated later on, but that's it for today's class. Again, I want you to make sure you know how to work this properly, because it's going to start getting complicated tomorrow. For homework, all you have to do is examples, or let me just write it down, 27 through 32. Note, and this is page 314. This is using the calculator. I repeat, using the calculator. Do not do these without using the calculator. I don't want you to call me up and say, Prof, how do I do those without a calculator? You don't. You use a calculator, okay? All of them. Calculator. No exceptions. These. Now these you do without using a calculator. Without using a calculator. Using the rules we just learned on just eliminating. It's pretty simple. You'll see. Pretty straightforward. Now, if you have any questions, let me know. We'll set up a video call. Otherwise, have a great day. I'll see you all tomorrow.